here it is. You can see it right here. Here's the URL to get them. It tells us the analyzers that it has. Now, it just gives us a little bit more information when we're working with a bit of Windows software. We can see what it's actually doing on the system, the pages in the file, the relocations. Right? It's a pretty cool tool. It's very powerful. Right?
Hey everyone, Yaniv Hoffman here, back with another video, and I have a special guest that been long time since he attended the show. Welcome, OTW.
Thank you very much, Yanif. I really appreciate being invited to your show and being able to address your viewers.
So OTW, I know you are working on a new book that is coming next year. Maybe you can share it with us. And I hear a little bird told me that you are planning some pre-order already with a nice discount. So I want everyone to enjoy this opportunity, maybe already to pre-order the book.
Yes, they're going to be we're giving half off for pre-orders. And if you pre-order for the first 1,000 pre-orders, we're going to stop at 1,000. Once we have 1,000, then we'll stop and we'll send you a personally signed edition of the book when it's published. So you'll get a physical book with a message from me, okay, to you on the inside cover.
This is the current cover, which is super cool. I love it. And you can see it's a very affordable for everyone, a bit shy of $25. And again, signed by OTW himself. So what we are going to speak about today, Occupy the Web.
Well, I've made a list over the years, and I've shared it with many of your viewers of the most important tools in cybersecurity. And I put them in my books and what have you. And in recent years, I've added a tool that I think most of your viewers probably at least have heard about. And it's called Ghidra. Ghidra was a tool that was developed by the US NSA. It's a tool for reverse engineering anything, reverse engineering, or at least disassembling. That's probably the best term for it, is disassembling software. So what you do is that you can put software into Ghidra, and Ghidra will disassemble it and show you what is actually taking place inside that software. Now, why would you want to know what's going on? Well, if it's malware, I certainly would like to know what it's doing, right? And in some cases, we can take malware and actually edit it. We can change it so that it's more useful. So if we want to use somebody else's malware and then re-engineer it and send it back out. Now, this is what all of the intelligence agencies do, whether it be the CIA or the GRU or Mossad. They all reuse each other's malware, but sometimes they just make small changes to it, and the small changes can add additional capabilities to it, and it can also help get it past antivirus. Right? So our antivirus scanners work mostly on a signature. Right? So they determine something's malware by a signature that particular piece of malware has. If I can change it, then the signature might be undetectable. So this is a really useful tool that can be used for a lot of different things, but I wanted to kind of introduce your viewers to it so they can get a chance to play with it. And we'll start today, and we'll do several more, I hope, more videos on Ghidra. We'll start off with just how to install it and how to how it works, and then we'll look at some real simple disassembly on some real simple tools, simple programs, and then in the future we'll actually use it on some malware and then see whether or not we can re-engineer that malware in ways that make it undetectable It's also important to note, this might be more interesting than some of your viewers, but if I can get inside of a piece of software, oftentimes I can determine its mechanism for authentication. Right? It's so like whenever we install any software, right, we have to have almost any software, we have to have a code, okay, that is we put into the software that enables it. Without that code, it won't work.
Right.
Well, one of the things that can be done is that you can get inside the software and look at that mechanism for authentication and then possibly get around it or bypass it. Right. So that's what we're going to do a little bit with today with we'll start off with some simple examples, and we'll in the future we'll do some more advanced with reverse engineering is a big topic in many universities. It's a whole year's program. In some cases it's more than a year. At Hackers Arise, we have a 3-part series. We have 3 different courses of introductory, intermediate, and advanced reverse engineering. So this is kind of like we're gonna talk about what reverse engineering is, what Ghidra is. This is on my list of essential tools, right? So if you really want to elevate your game in cybersecurity, it's one of those tools that you probably want to be familiar with.
I agree, and I love it, and I think it will be beneficial for all the viewers, from beginners to advanced, and definitely if you want to enhance your toolbox as a hacker, that's the opportunity.
And the beauty is that's free.
It's an open source.
It's free and open source. And one of the things, I think it was 2019 that NSA first introduced this tool to the public. They released it to the public in 2019, and a lot of questions came up at that time about why was NSA releasing it, and were there back doors into it, and if you put it on your machine, would NSA have a backdoor into your system? Nobody yet has found, and I have not found, and I can say that I have not found any backdoors into this software. So those people who have some reservations about it because of possibility that's coming from NSA, I think that might be overblown. I think the NSA wants to enhance the cybersecurity community. That's why they've given it away for free. Is they want more people who are trained in reverse engineering. So they released a really good tool and made it free. And this tool used to be that to do reverse engineering, you had to spend thousands of dollars on tools. This tool is free and has almost all the capabilities of the more advanced and more expensive tools that are on the market. So that's why we use it for our training at Hackers Rise. Let's start off let's talk a little bit about Ghidra. Okay, Ghidra developed by the NSA, right? And so you can get it for either Windows or for Linux or for Mac because it's a Java application. So it means it'll run any place, right? I'm going to show you how to install it on both Linux and on Windows, right? It's going to be pretty much the same, but let's go ahead and it's real simple in Kali. Let's do that first. All right, I have it set up over here, but let's clear here. And I'll expand my screen, right? And probably it's the simplest to install on Kali. And so let's start there and we'll look at how to do it in Windows too. So let's, here's Kali. This is this is the most recent one, 2024-3. I'm running it in virtual VMware. I recently have had a lot of issues with VirtualBox. So I've gone back. And now, the nice thing about VMware is they've released it for personal use for free. So it used to be that it was $150, $200, which is still pretty reasonable. But now, for personal use, you can get it for free. So I find that it works better than VirtualBox most of the time. So
Yeah, I
that's what.
agree. I agree. I started to transform to VMware as well because I had also some issues. But yeah.
I go back and forth, and in most of my classes, I've always tried to use VirtualBox
Mhm.
because it's free, and the students, don't necessarily have a lot of money to spend on
Right.
commercial software. So, but now that and I've always thought VMware is better, but I've been using VirtualBox in with you and I, and, in my classes, I've used VirtualBox. But now that it's free, I think it's superior to virtual. I think VMware is superior to VirtualBox. And in recent activities that I've been doing, I've just had a lot of problems with VirtualBox. So I don't want to knock VirtualBox too hard. But if it's free, they're both free. Why not go with
Yeah, makes
VMware?
sense.
Okay. So what we want to do, okay, is that it's now in the Kali repository, which tells you that it's pretty popular, right? It's a lot of people are using it. So it used to be you had to download it from the Ghidra. Ghidra has their own GitHub repository, but we can get it here. Pretty simple. We can just go sudo apt install
Ghidra.
Ghidra, Ghidra, or Ghidra, or Ghidra. It's call it whatever you want. Okay, so that's all you need to do. I've already have it installed here, and so it's pretty easy to work with. It takes a few minutes. It's a pretty big piece of software.
Mhm.
One of the nice things is that it requires the JDK, Java Development Kit, right? And when you're putting it into other operating systems, you often have to go download the latest JDK, the runtime JDK. But with this package, everything comes included. So we can simply go ahead and type Ghidra, and there we go.
It's very
This is
convenient.
the
Yeah.
this is the latest one. I think I just downloaded it today or yesterday, right? So
Mm-hmm.
it hasn't changed dramatically, but it does change, right? And so if you're doing it on Windows or a Mac, let me just show you the website. And there it is. And you can go ahead and download it from GitHub. And there's videos for the installation guide, and they have a whole manual that they've developed. There's also a really good book from No Starch Press on Ghidra, and there's other books as well, right?
Mm-hmm.
And they have a community as well. You can download this and into your Windows or your Mac system, and then you have to go ahead and get the latest JDK. In the case of Windows, you actually have to get the Windows JDK from Microsoft, right? So that's an important thing to keep in mind. All right. So let's go ahead and take a look at this tool. When you open it up, it looks like this. There's no active project. Right. So what we want to do is we're going to go ahead and start a new project. All right. And we can either do a shared project or a non-shared project. In other words, if you're working on it with other people, that would be a shared project. If you're doing it by yourself, it's going to be a non-shared project. And then go there. And then we're going to go, let's see, we'll call it hackers, hackers, hackers arise. Let's see if it'll take that. Okay. Uh, First, RE project. Okay.
Mm-hmm.
And then let's go ahead and finish it. All right, there it is. So we have a project now. And then once we have a project, we can go ahead and put the software into the project. And Ghidra works really well with simply a drag and drop. All right. And so I've got some crack me's. These were developed as simple tools to learn how to use reverse engineering. They're all 32-bit Windows applications, and it's a good place to start. So what's what we're going to be doing? And let's see, we got on my desktop here. I've got the O2, I got O1, I have O. Let's start with that one. This is the first one. And let's go ahead. We can just drag and drop it into here. And you can see it pops up and says it's a portable executable. Okay, it tells me what language it's written in. You see it's a x86, okay? It's a default Windows, puts it in the destination folder, and that's the crack me 0x00exe. So it's a portable executable is the standard format for an executable in Windows, right? So that's what we're going to be doing. Let's go ahead, hit enter, and we pops up. This is the screen we get. Let's take a look at this and see if I can get it all on the screen. You can see it gives me some basic information. We don't need to see the very top there. It says last modified at the top, read only. Okay, and it says false. It gives me the name of the file, the language, okay, the compiler, the processor. It tells me endian. It's little endian. Okay, so little endian sounds like a little Indian, but really what it means, it's a way that different processors, different operating systems read the binary data. All right. And so this is address is 32, gives me a minimum address and a maximum address. And so we can just go ahead then and hit OK. We can then start by double clicking on this. And you can see the dragon, the Ghidra dragon appears. All right. And so, oh, by the way, I guess let me just point out that these crack me's are available. Let me just give you the website that they're at, so that so that others can.
I was going to ask about it. We leave it in the description. Yeah.
Yeah, I'll put it up. Let's see, it's at. I'll put it in. And they're simple. They're meant to start place to start with doing reverse engineering. So these are really useful to get a start. And he has some others in here, but we'll just use the simple ones to start. And then next time we're together, let's do something a little more advanced. But here it is. You can see it right here. Here's the URL to get them. And you can see it right over here.
Yeah.
So let's go ahead, and it says here, crack me has not been analyzed. Would you like to analyze it now? Of course. Why do you think I'm here?
That's why
that's why I'm here. I'm here to analyze this. What do you think I'm doing? Anyways, let's go. Yes. All right. And so this is kind of interesting, right? Is that it tells us the analyzers that it has. Now, doing decompiling of software is not a simple task. It's really pretty complex. Think about it, is that it's taking the software and breaking it down into, first of all, the assembler, right? So a lot of software, most software that's not open source, we can't see the code. But what a disassembler like Ghidra allows us to do is actually disassemble it by reading the assembler, right, of the code and then rebuilding up from there. So it disassembles it down to the assembler language, right? And then it can build it back up usually into C, right? So what it does is it allows us to do a lot of different things, right? And most of them, the defaults are just fine. I would say possibly just to click this one in addition. This analyzer uses external window function called parameter information to populate the comments next to the pushed parameters. It just gives us a little bit more information when we're working with a bit of Windows software, right? And this is a Windows x86. So let's go ahead and analyze it. And let's take a look at what's going on. All right, so we've got a number of windows here. And let's break these down so people who are new to it can understand what's going on. All right. So over here, right, this area right here, these are called program trees. Okay. And then we have symbol trees over here. So these gives us the different program trees gives us the different portions of the code. Right. It gives us the headers, the text, the data, the R data, the BSS, and the I data. Right. Over here, we have symbol trees. So this is going to include the imports, right, and the exports from this particular. You can see that it exports a main CRT startup function, right? And then here we can see all of the functions, all the functions, right? So a function basically is a bit of code that does some particular task, right? And so we can see all the functions. We can see the labels, okay? We can see the classes and the namespaces. And then we have down below here, we have the data type manager, all right? In this area right here, all right, this is referred to as the listing window. This is showing us this piece of software in assembler, right? Now, for those of you who aren't familiar, assembler is very close to machine language. It's like the most fundamental and basic type of language. It's everything requires multiple commands to get even the simplest task done. But
Right.
this is something that the source code, okay, can't hide from us, right? We can see what it's actually doing on the system, right? And you can see each of the it has comments over here as well, showing us bytes of the last page, the pages in the file, the relocations, right? The size of the headers. So this is basically the image DOS header up here. And then we can scroll down a ways and we can actually see the work that it's doing, right over here. All right, so this would be lab 00401-590. And here it's a move, okay, from the EAX, a double word to pointer. If I hover over it, it gives me a lot more information, like right here, right? We go even deeper. And we'll do some of this in future lessons, but mostly today I wanted your viewers to get familiar with how to start in it. These are all comments over here explaining what's going on. So it's a pretty cool tool. It's very powerful, right? One of the things that almost everybody does when they first start out in doing any type of reverse engineering is to look for, first of all, for strings. Right? So we're going to look for strings in the code. Why do I look for strings? Because strings can often give me a clue as to what's actually going on. Right? We can go up here and go search and look for program text here, or we can go for strings and scalars here. Let's go look for strings. All right.
When you're
And
searching strings, why it's so important? Or
okay, a couple things why it's so important. One, okay, is that oftentimes well, in most cases, in standard software, non-malware, the developer oftentimes will put comments in, and comments are strings. So for those of you who haven't heard that term before, maybe English isn't your first language, strings are just a information technology term that refers to words, right? It's it's a bunch of characters together, a bunch of alphanumeric characters together. That's what a string is. And so by searching for the strings, I can get clues as to what the programmer was trying to do, what notes they left for themselves, right? It's also in malware, it's also very useful to check out the strings, because sometimes the strings can reveal who actually wrote it, right? And the first thing you're going to detect is, what language is this written in, right? If the comments are written in Russian, it's a good chance that it's written in Russia. If the comments are written in Korean, it's probably Korean. If it's written in Chinese, then it's probably Chinese. If it's written in English, it could be anybody because English is used around the world. But this is the first step. This is the first thing you do. And even in sophisticated software, you'll often find a lot of information simply by looking for the strings, right? It also can give you a clue as to the heritage of the malware. So by looking at the various components and the various strings in the software, I can get an idea of not only who wrote it, but maybe where they got their components from. Right? They might have borrowed pieces of this malware from somebody else. This is very common, right? You know, every intelligence agency, every criminal hacker, no matter who it is, they reuse code just like a standard programmer does. A standard programmer doesn't reinvent the wheel every time they want to go ahead and write a program. They use pieces that have already been developed that they know work. Why go ahead and rewrite that piece when somebody else has already done it? The
Right.
same applies for malware, okay? And this can often lead to attribution of who wrote the software, right? And the FBI and the CIA have very often been able to determine who wrote the malware by just simply searching for strings. All right, let's go ahead and we can see here that the minimum length. So we don't want to look at strings that are um, less than 5 characters long, right? And so let's go ahead and we can make this whatever number we want, but in this case, by default, it's 5 characters. Let's leave it at that. And let's go ahead and search. Go and see if we found, oh, we found a few things, right? You can see right here that here's the name of the program. Of course, that's going to be in there. Here you have
Password. Yeah.
a password, right? And over here you can see we have a password.
Probably a password. Yeah.
Probably a password, right?
Yeah. Yeah.
So this is part of the code, and we can go through and once again, this is a simple piece. It's used for beginner level reverse engineering. You're not always going to find the strings that are useful to you so easily, but here we do. Many of you probably remember that in 2017, right, there was the WannaCry software.
Right.
WannaCry was the ransomware, right? And Marcus Hutchins, right?
Yes.
So one of the things did some amazing stuff, right? He basically saved the world from the WannaCry malware, right? So it's 2017, and that's kind of a key year because 2017 was the year that the Eternal Blue exploit was released, right? And it was put out on the web, and everybody, all the criminal gangs, it's NSA developed malware that allowed basically the NSA to break in to just about any machine in the world, any Windows machine
Right.
in the world, right? And so once that was stolen from the NSA and then it was released out on the web, lots of criminal gangs simply used it. Okay? Why reinvent the wheel? Go and use what the NSA has already developed, and they were using it to attack Windows systems and then install ransomware on it. So, as your viewers know, ransomware basically has two primary components, right? The first component to ransomware is an exploit to get inside of the machine, right? To get inside the machine. Now, sometimes they're not that sophisticated. Like sometimes it's just simply a social engineering attack to get people to click on a link and get inside the system that way. The beauty of the Eternal Blue is it didn't require any social engineering, right? It allowed the attacker to exploit a flaw in the SMB, okay, the server message block, port 445. And once it was able to exploit, because it was actually a problem with SMB1 and SMB2, okay? When it exploited that, it was able to put code, remote code execution, onto the system. And it could be a shell code, or in many cases, in WannaCry and Petya and not Petya, what it did is it put in an encryptor into the system. And so what it would do is it would go into the system and it would first look for all of the files that ended in like JPEG or doc, PDF, or SQL. So all the important stuff. So that's the first thing it does. It goes in and looks for all the important stuff in your system, and then it starts encrypting it. All right. And then the encryption algorithm, that's not that's not rocket science because there's lots of encryption algorithms that have already been written. So once you're inside the system, the malware is, then it simply uses off-the-shelf encryption, right? And but the key is that it's using off-the-shelf encryption that can't be reversed easily. Right? So the target then has all of their key files unavailable. They're encrypted. They can't do anything with their system anymore.
Mhm.
And the criminal gangs have found that particularly hospitals have been among the most lucrative targets because a hospital can't wait, right?
Right.
They've got surgery to do right now. They got people dying, right? They cannot wait to bring in a forensic investigation team that's going
Right.
to determine who did it and then try to reverse all the encryption. It has to be done now. So they pay. In any case, so Marcus Hutchins, one of the first things he did is he did exactly what we did right here, right? And what he found is that he found a string that was a URL, right? It was a URL. And that URL pointed to the command and control server for WannaCry. In that case, that particular piece of software was not, nothing was encrypted. In other words, it was no obfuscation. It was very similar to what we're looking at right here, that everything was basically in clear text.
Yeah.
So he goes in and he sees, right? He sees this URL and he goes, and it looks like this might be the command and control URL. He goes and tries to connect to that URL and he finds that it doesn't exist, right? So he goes and registers that URL in his own name. And it turns out that the developer of the malware of WannaCry had failed to register. They were in such a hurry to get the malware out because they knew there was a very small window that that Eternal Blue was out there and people were beginning to patch their systems.
Right.
And so there was a very small window to get the malware out. And so they rushed and they put it out without registering the URL. And the URL was kind of, it wasn't a name of anything. It was just a bunch of characters. And so he went and registered it. And so when the criminal gang went to set up their command and control server, it wasn't available to them. And so some people that say that Marcus Hutchins saved the world, saved the internet, right? And he did it in a way that was relatively, well, he was doing it on a piece of software that really wasn't that sophisticated. I'm not taking anything away from Marcus. I
Yeah.
admire him, right? But in that case, all he had to do is do a strings search on that malware, and he found what looked like a URL, and then he registered it. The sad part of this story is that because Marcus was so adept at finding that kill switch, as it's referred to, basically what he found was a URL, right? So the kill switch was basically disconnecting the URL, the command and control server, from WannaCry. But then he got charged. Okay, he got charged with a felony and was arrested in the United States, right? Um, because once he was able to do this, they said, "Oh, who is this guy who was able to figure this out so easily? He must be involved in developing it." Right? Because they didn't really realize that, for somebody who's adept at reverse engineering, and I think he used IDA Pro, which is the IDA Pro is what's been the standard for years and years and years, and it's still around. It's an excellent piece of software, but it's a couple of $1,000s, I think, the last time I looked. And so he used it, and he got about this far in his analysis and saw the URLs. So, and in all honesty, this is what a lot of times the FBI and other law enforcement does when they got a piece of malware. The first thing they do is look at strings. And it by looking at the strings, we can get some clue as to what's going on. Right? In this case here, it was pretty straightforward. We can see the passwords embedded here. So this is a simple piece of software where you have to use a password to access it, right? And we can see that it's embedded right there. There's the password. And once again, in the case of Marcus, he found the URL by simply doing a string search on it. Pretty powerful stuff. You too could have saved the world if you had Ghidra.
That's why we are doing it now. Maybe we have the future heroes here that will find.
Right. So those of you who are out there who want to save the world from the next ransomware attack, pick up reverse engineering skills and Ghidra. And the first thing almost everybody does is simply do this string search. Okay. And it revealed a lot to us in just a simple search, right? But you can also see, then we go over here, I'm going to close that down, is we can see over here, there's a decompiled, okay, the main. So what it's done is it's decompiled the main function. Okay, the main function is the heart of the program. If we can go through this and look at it, and what it's done is it's taken the assembler and attempted to rebuild the C commands, right? So it's not necessarily rebuilding the original code, because this code might be written, well, we know that this one, I don't know what, I'm not sure what it was written in, but it can go ahead and try to rebuild it in C. That's not that hard to do. It's easier to do that than some other languages, right? So we can see what's going on here. We can see here's the main function right here, starts right here.
Right.
And then we see a print statement. Okay, that's pretty straightforward what that's doing, right? As we hover over it, right? Every time I hover over any of these commands, it gives us a lot of information about it. Okay, it shows me what the integer is. It's the EAX4, which is a command in assembler, right? And then it over here gives me, I hover over the IO. This is IOLI, crack me level 000x00. All right, that's just basically a print statement. And then another print statement says, hey, what's the password? All right. And then it goes ahead and does a scan F, looking for the entry of the user. All right. So it says, okay, user, what's the password? And then it picks up that password that's entered. All right. And then it does a string compare. That's what that is. STR compare with the local LC, that's that right there that we entered, with this number right here.
Yeah.
It's just comparing them, right?
Yeah.
So it has, here's the stored password, here's the number that we entered in as a password up here, or it doesn't be a number, any password is stored here in local LC.
Yeah.
And then it's gone ahead and says, okay, compare those two. All right. Yeah. If if variable 1 is equal to 0, right? Then
no differences.
Yeah. So if they match, it'll return a 0.
Yeah.
Right. If they match, it returns a 0. That's what string compare does. String compare simply has either 0 or 1. So if they match, return a 0. If they don't match, then go ahead and return a 1. And so you can see here it says, and then if it's a 0, print F, password's okay. All right. Else, okay, this is an if else, real simple programming. I want to also plug my upcoming book while we're talking about this here. I just announced that I have a new book coming out, Python Basics for Hackers, and we started taking pre-orders just this week on it. So if anybody's really interested.
Yeah. So if anyone is interested, we'll leave the link on the screen and in the description. So definitely, that's exciting. I knew it's coming.
Right. It's a new book that we've been planning for a while. And so we just announced it. And It's available for pre-order, and if people pre-order it, they get 50% off right now,
Wow.
and they get a signed copy. Not only do they get it half off, but they get a signed copy that we will physically ship the book to them when it's published.
Wow.
So
Okay, so
so
I
this
need
is
to be one of the first. So,
yeah,
so,
you'll
so
be one of the first.
yeah, so OTW, I'm happy you touch it. So what I like in Ghidra, you don't necessarily need to be a programmer to use Ghidra, but having
Right,
some programming knowledge is definitely helpful. And knowing languages like Python, as you mentioned, even the basic, or Java is beneficial. Um, if you want also to write custom scripts to automate tasks in Ghidra, right? But
right.
the requirement is only basic. You don't need to be a top expert. We saw
You
it's very
don't Yeah,
easy.
you don't have to be an expert because you can see that just some basic programming. Now, to read this in here, the assembler,
Mhm.
that takes a lot of skill.
Right, right.
Okay. But very few people can read assembler. Very few people can, right?
I
And
learned it
that's why,
20 years ago in the university. Yeah. So,
do you remember it all?
yeah, no, no, definitely not.
Very few people do,
Yeah.
right? And so, but this is C over here. Right? And it's pretty, you can,
Yes.
with just a little bit of knowledge of programming, right? You can kind of figure out what's going on here, right? So, you can see here the print statements are pretty standard, right?
Yeah.
You might not know what a scanf is, but basically what it's doing is it's taking an input, okay, and putting it into a variable, and then it's taking that and making a string compare. That's what that is. str compare, right? And it compares this variable here to a number, right?
Right.
And then it just goes and checks to see whether the result of the compare is either 0 or 1. That's all it's checking for. If it's a 0, then the password is correct. If it's a 1, then the password is incorrect. And
Mhm.
the other thing that a some basic programming would help is doing an if statement. This is an if, and there's no the then is implied here, and then else, right? So it's if the variable 1 is equal to 0, print. Password's okay, right? So there's an implied then. Many of the programming languages in recent years have taken out the then and they just imply the then. So if this is true, then print this, else print this. All right. And so we can go ahead and try this. I got this program set up here, right? It's in the Windows. It's a Windows program. Here is the program. It's a simple program. Like I said, it's just a way for people to get started in reverse engineering. So it was designed for that purpose. It's nothing fancy, but it's a good program to start testing and learning skills in how to disassemble and read code. That's what we just did here, but this is a pretty simple one. So let's go ahead and just run this program. All right. And I'm going to go ahead and hit enter. You can see it comes up. Remember that when we were disassembling it, that we saw those strings that we see right here, right? So if I go ahead and put in my password, okay, like that, it comes back and says
Not match.
invalid password, right?
Mhm.
But we learned by going inside the software that there is a variable that stores the password, right?
Yeah.
In You're not going to see that very often in modern software. Oftentimes in modern software, there's actually an algorithm that determines whether or not the software is accurate, right? In some cases, you might find a stored password, but more modern software, they have an algorithm that determines whether or not the key that you put in is accurate. So it would be a little more complicated than what we're doing here today because you would have to then figure out the algorithm. And then once you figured it out, then you know what keys will work to be able to uh, enable the software. So let's try it now. Remember, we looked earlier and we had we found a string that had the password in it. Let's try and see what happens there. All right. So let's go. I think we saw it was 250, right?
Mhm.
382, right? That was the string that we saw. It's a variable that's stored in the program for the password, and we can see password is okay.
Okay.
So this is the simplest type of basically cracking. I mean, that's what we're doing here. We're cracking the software to be able to determine what the password is. And this is the simplest type of cracking is done. Now, so let's go ahead and I'm gonna have to change screens here. Right
Yeah,
here, it's in
the
this,
invalid. Yeah.
it's in the C code right there, and it's also we found it by just doing a quick search for
Search.
strings. And yeah, this might seem simple, but quite frankly, it's what everybody does in reversing. It's the first step. You know, there's I always say that always try the simplest things first. You know, you don't want to go and have to decipher all the assembler language to be able to figure out what the password is when it's sitting right
Good.
there in the strings, right? And
Good.
so this is the simple part, right? But this is the first part, and I can tell you from experience that this has led, just doing a string search, a simple string search, has led to a lot of criminal activity being attributed. I mean, attributed means knowing who did it, right?
Yeah.
So you might have remembered that, there's lots of cases I can think of, but then the Sony hack a few years ago, what was that, 2014 or something like that? This is the way that the FBI figured out that the Sony hack came from North Korea because they went through the strings and were able to find lots of references in Korean, right? So you can see it right here. It's very simple. And this is always the first step.
Yeah.
All right. So let's go ahead and close this one down. And let's just take one step up. All right. I'm going to close down Ghidra entirely like this. I'm going to say, no, I'm not going to save it. Unless I don't save. Okay. So next step, what we're going to do is take one step up and we'll go to something that's a little more obscure, a little more difficult. Okay. And maybe we can do in future classes or future videos, we can do, like I said, we'll do some more advanced and more complex malware, but everybody has to start somewhere, right? Everybody, even the greatest expert, has to start somewhere. They have to start with the simple, and that's what we're doing here today. Starting with the simple stuff so you can at least get comfortable with the way that this tool works, right? So let's go ahead and we just did another crack me. This is 0, 1, so it's the next level up. Yeah. Then we can see here, it gives us the basic information about this um, particular piece of software. We can't call it malware because it's not. It's just simply a piece of software that requires a password, right? And so we'll go ahead and hit OK. I think that for some of your viewers, they might have wondered, like, how do people go ahead and crack software? Like, this is how they do it.
Yeah.
So, some of you might have some on your computer right now that has been cracked, right? That you've gotten. This is the process, right, of going ahead and cracking the software. Okay, let's go ahead and get our dragon going here. And it tells me it hasn't been analyzed. And of course, that's what I'm here for, guys. So go ahead and do it. And we're going to go ahead and do a Windows PE. And we'll tell it to analyze. It takes a minute or so. Okay. And so this is a relatively small piece of software again. So it does it pretty quickly. But sometimes in complex software, you can go out and get yourself a cup of coffee while it's doing its work. Right. If it's really big and complex software. Because really decompiling is really a complex task. So you have to give a lot of credit to the guys and gals who wrote this stuff because it takes a lot of knowledge and a lot of work to be able to build one of these. So we got another one. This is this is 01. And we'll just go over here and do our search again and see if we can find anything that's interesting in the strings. Okay, let's see what we have here.
Mm-hmm.
It comes back, this string right here is common in Windows software right at the top. This program cannot be run in DOS mode. You find that in the header of a lot of Windows software, and then you see the various sections, right? You can see these sections are over here, right? That's what these strings over here are. And then it tells us the name of the software, which is inside the program itself. Aha! We see password. Okay. But unfortunately, we don't see any password. Oh, darn. Okay. So let's go ahead and close this one. And then let's go over here. Once again, it looks almost exactly the same as the previous one,
Mm-hmm.
but there's no password. So what we can do here is we just go through this real quickly. This is an allocation of memory here. Then here's the beginning of the main function, which is the center of a lot of different programming languages. The key, the heart of a program is called the main. Okay. And then we have the printf, which is the aioli crack me level, right? And then it says printf password. And then just like the other one, it says scanf, okay, is looking for our input. That's what it's doing, is it's picking up the whatever we entered in the keyboard. In the previous one, we saw the password. Right? In this one here, look at what it does is if the local 8, right, which is this input right here, is equal to, okay, and we just got a bunch of hexadecimal numbers there. Then, the implied then, printf, password's okay, all right? And then else print the invalid password and then return. Now, one of the beauties of what this program and other programs similar to do is I can just hover over, say, this right here. I'll hover over a second, and you can see that what it does is it converts that hexadecimal automatically into decimal. There it is right there. I'm going to go ahead and you see I right clicked on it. If I hover over it, I hovered over it, I get this, but you can see that the decimal might be cut off a little bit. Let's see if I can do it
Right.
again. Yeah, it's only
Yes.
showing two digits. Right. So if I right click on it, okay, I get this whole output. Oh, I guess it did give us the whole thing. It's
Right.
5274. That's the decimal equivalent of that hex. Right? So as you know, hexadecimal is a base 16 program, a base 16 numbering system, and we use it in a lot of areas in IT.
Mm-hmm.
For instance, your MAC addresses, okay, are all in hexadecimal. There's lots of things that are in hexadecimal, but you probably have seen hexadecimal in just your MAC addresses of your network interface card. That's all in hex. But lots of things are in hex, right? Because everything in the computer is base 2, so it's easy or relatively easy to go from base 2 to base 16 hexadecimal. So hexadecimal goes from 0 to 9, and then A, B, C, D, E, F, right? So F represents 16, okay? And so we can see if we look at this again, we can see that it says, okay, we have a 1, a 4, a 9, and an A, right? And that converts into a decimal equivalent of 5274. So it's just a slightly more complex, a little more obscurity, but a program like Ghidra makes quick work of this. It converts that for us. Of course, we also have on our Windows machine or Linux machine, we can always have there's different applications that convert hex to decimal. So now that we know what the password is, this looks to be the password. It's testing, right, to see whether or not, okay, that input local 8 is equal to this hexadecimal password. And we know that's 5274. Let's give it a try. So now let's go ahead and run this again, but let's run it through Crack Me 01. All right, and you can see that it comes back. There's our strings that we saw in the code, right?
Right.
And we now know that the password is stored in a variable in the form of hexadecimal. But in our case here, we can, well, let's try entering it as hexadecimal, right? Let's first of all, let's just try entering a random password.
Yeah.
Comes back as nothing, right? And then let's try entering it in terms of hex, right? So let's go, then enter the hex, okay, 0x, okay, 149. Now, sometimes with some programs, you can put the hexadecimal password in. In some cases, you can actually, if you have the hash of the password, some cases you can pass the hash. If you don't have to know the password, you just have to grab the hash
Unbelievable. Yeah.
and and then pass the hash to the program. Let's see if this will work here.
Yeah.
Nope,
Yeah.
didn't work. Okay,
A bit more
let's try,
sophisticated, yeah.
and then let's try running it again, but let's try using the decimal equivalent of that password. All right, and that in this case here, I think it's 5274, right?
Yeah, yeah.
Uh,
You're
short, short. Let's try that. If not, yeah, we
okay,
got it.
perfect.
All right. So these are two simple examples of basically tracking the credentials on a piece of software. So
Yeah.
disassembly can be used for a lot of things. And one of the things that can be used for is cracking the credentials, the authentication mechanism in the software. And this was a pretty simple authentication mechanism. In one case, it was in clear text, and the other was in hexadecimal. And in the more complex, you'll see in more complex software that it's actually an algorithm that you have to then be able to decipher.
Mhm.
But I think what we've done here today is simply introduce your viewers to a really important tool, a very important and powerful. When I made the list of the most important pieces, most important cybersecurity tools, I think I did it. I put it in Network Basics for Hackers. I put it in that one. This has only been around for 5 years, so it's relatively new. I mean, it all depends upon your perspective of what's new. It's also is in terms of your work, if you're working for a cybersecurity firm and you're called on to be able to decipher what a piece of malware does or who sent it, Ghidra is a good place to start because it can do that for you. And so I just want to encourage all of your
Yeah.
viewers that get familiar with this tool. It's a good tool. And don't be concerned that it was developed by NSA, right? So, a lot of people, including myself, have looked at it very closely, and we don't see anything in there that is worrisome, right? There doesn't seem to be any backdoors, which is what a lot of people were worried about when it was first released. But I think you're safe. But I think the NSA truly just wants people to be good at reverse engineering because the more people who are good at reverse engineering, the better that their staff and their team becomes. They get better people coming in.
Yeah.
One last thing I wanted to say about this particular tool is that once I decipher how the tool works, right? If I am NSA or I am Mossad or I am the GRU, I
Mhm.
can take somebody else's malware, and you see this all the time. If you do malware analysis, you see this all the time. You see malware that's been re-engineered so that what I do is I capture somebody else's malware, right? That is very effective, and then I make some changes to it,
Right.
either to make it more powerful or to make it more difficult to decipher. It's called obfuscation,
Yeah.
or I can add new features to it, right? And the other thing I think I forgot to mention is that I might be able to make some changes to it so that it's not detected by AV. So, AV, most AV can detect what it knows about. if you take a piece of malware and make changes to it, the signature that it has stored in its signature database might be different now. Right? And AV software is evolving and getting better and better all the time. And so it's becoming harder and harder for the malware developers to hide from AV. But one of the things, the first steps that you would try to do to get past AV is to change the code. Okay, it's often referred to as re-encode it
Mhm.
so that its signature is not the same. If it doesn't have the same signature, it can possibly get past antivirus detection.
So thank you everyone for watching this introduction into Ghidra with the incredible OTW. We hope you gained valuable insight into how powerful this tool is in unrevealing complex code and defending against cyber threat. A huge thank you, OTW, for sharing your expertise and giving us an insider look into Ghidra capabilities. It's always inspiring to learn from the best in the field. Now, guys, if you are passionate about cybersecurity or just starting out, remember that tools like Ghidra are just one part of the journey, and there is a whole world of knowledge out there. So stay curious, keep learning, and don't forget to subscribe for more content just like this. Thank you again, OTW, and thank you all for being here.
Thank you, Yanif. I really appreciate your having me on again. And I look forward to coming back and showing more about Ghidra with a little bit more complex examples. But we'll start with the simple and work up from there.
Would love it. Thank you very much.